If you click this video hoping to learn how to teleport your ex out of your life, I have bad news. But if you click this video hoping to learn how to teleport information, like the actual quantum state of a particle across space with no particle physically traveling, I have fantastic news. Because quantum teleportation is real. It has been done in laboratories, over city-scale distances, and even from Earth to a satellite. Now, here's the twist sci-fi never tells you. Quantum teleportation doesn't teleport stuff, it teleports state. Not people, not atoms of your body, not your sneakers. It teleports the instruction set of a quantum system. And the original is destroyed in the process. So today, you and I are walking straight into the transporter room of reality and seeing what physics actually built. Let's do it. Imagine you have a qubit, quantum information, stored in a particle. A qubit isn't just 0 or 1. It can be a weird mix, like part 0 plus part 1, until measurement forces a final answer. Now imagine you want to transfer that qubit to someone far away, but without copying it. Because nature has a strict rule. You cannot clone an unknown quantum state. That's the problem quantum teleportation solves. And it solves it with 3-ingredient recipe. 1. Entanglement, a shared quantum link. 2. A special joint measurement, a Bell state measurement. 3. 2 classical bits sent normally. No faster-than-light cheating. This protocol was proposed in 1993 by Charles H. Bennett and colleagues, and then humans actually built it. Here's a simple truth civilization learned early. You don't move the king, you move the message. Roman roads, Persian couriers, semaphore towers, telegraph wires. Empires discovered a principle: control the state, not the substance. You don't ship the entire library, you ship the instructions to rebuild the library, the letters. Quantum teleportation is the most extreme version of that idea ever invented. You don't ship the particle, you ship the state, the invisible quantum shape of its information. But nature demands a price. In every teleportation story, we have 2 classic characters: Alice, the sender; Bob, the receiver. Alice has a qubit in a state we'll call psi. And here's the problem. Alice may not even know what psi is. If she measures it to find out, she destroys it. If she tries to copy it, physics says absolutely not. So we need a method that transfers the state without copying it and without Alice learning it. This is where entanglement becomes the plot device that feels so powerful it should be illegal. Now, follow this trail carefully and you'll understand quantum teleportation better than most movie writers. Step 1. Share entanglement. Alice and Bob share an entangled pair. They create 2 particles, call them A2, Alice's, and B, Bob's, that are entangled. Entanglement means their outcomes are correlated in a way classical physics can't simulate cleanly. Step 2. The Bell state measurement. Alice performs a Bell state measurement on 2 particles, A1, the particle holding psi, and A2, her half of the entangled pair. This does something violent and beautiful. It destroys the original state in Alice's possession. Important, no copy remains. And it projects the combined system into one of 4 possible outcomes. Step 3. Send 2 classical bits. Alice sends Bob 2 classical bits describing which outcome she got. This is normal communication, light speed limited, like texting. No cosmic cheating. Step 4. Bob applies the correction. Bob applies a correction based on those 2 bits, and boom, Bob's particle becomes the original psi state. So the state has moved from A1 to B without A1 traveling. Key point: nothing here allows faster-than-light messaging because Bob needs Alice's classical bits to finish the job. Entanglement is like receiving a mystery lockbox from the universe, but the key arrives later by regular mail. At this point, your brain will try to arrest physics. Hold on, if Bob ends up with Sci, didn't we just copy it? No, because Alice's measurement erases the original state during the procedure. Teleportation respects the no cloning rule by transferring through destruction. Think of it like this. Classical copying is duplicate the file. Quantum teleportation is cut and paste, not copy and paste. But it's cut and paste where the clipboard is entanglement, and the paste command needs 2 classical bits. The theory arrived in 1993. The experiment arrived in 1997 when researchers demonstrated quantum teleportation in photonic systems. One landmark demonstration is the 1997 Nature paper, often cited as an experimental principle for teleportation of a quantum state. And soon after, experiments also demonstrated teleportation of unknown pure quantum states in optical setups, published in physical review letters. So yes, the universe let us teleport quantum states, and we immediately used it on photons, the particles that already refuse to sit still for a passport photo. Let's go deeper, but keep the rope tied to the surface. A quantum state is not a little marble sitting somewhere with a hidden sticker. A state is a full description of what outcomes you'll get when you measure in different ways. It contains phases and amplitudes, things you can't extract completely from a single system without destroying it. Teleportation transfers that entire state structure onto Bob's particle, without Alice learning it. So teleportation is not moving matter, moving energy, moving a soul, or sending a secret faster than light. Teleportation is moving the quantum information structure of a system. Okay, if teleportation doesn't move people, why should anyone care? Because teleportation is basically a backbone move for quantum networks, quantum repeaters, and eventually a quantum internet. Why? Because you can't just amplify unknown quantum states like classical signals. Amplification would copy, and copying violates physics. Teleportation becomes a tool for moving fragile quantum states across long distances, piece by piece, using entanglement as infrastructure. And teleportation started as a lab trick. Then it began escaping into the wild. In 2012, a team demonstrated quantum teleportation over 143 kilometers using free space links between the Canary Islands, La Palma, and Tenerife, with real-time feed-forward. That's not science fiction, that's engineering reality. At 143 kilometers, your quantum state has traveled farther than some people's long-distance relationships, and with less emotional uncertainty. And then came the moment that sounds like a headline writer got too excited. Ground-to-satellite quantum teleportation. In 2017, a Nature paper reported teleporting independent single-photon qubits from a ground station to a satellite in low Earth orbit over distances up to 1,400 kilometers. That's one of the clearest signs teleportation isn't just a cool demo. It's a stepping stone towards global-scale quantum communication. Another deep layer, teleportation isn't limited to photon. Researchers have demonstrated teleportation between light and matter. That matters because photons are great for moving information, flying qubits, and atoms or ensembles are good for storing it, stationary qubits. This is one of the dreams behind quantum networks. Send with light, store in matter, connect the planet. Now, skeptic in the back row, arms folded. How do we know this isn't just a fancy classical trick? Because experiments report fidelity, how close the output state matches the input state. And there's a known benchmark, a classical limit. If you don't use entanglement, you can't beat certain average performance thresholds. Landmark experiments report fidelities beyond classical-only performance. So teleportation isn't spooky marketing, it's measurable. Now the question everybody asks, so when do we teleport people? Here's the honest answer.
Quantum teleportation is about one quantum state at a time, or small collections in advanced setups. A human body is not one state. It's an astronomical number of interacting particles entangled with the environment, constantly decohering, exchanging heat, and changing every moment. To teleport a person in the sci-fi sense, you'd need to capture the quantum state of an impossibly complex system, transmit that information, reconstruct it perfectly elsewhere, and destroy the original because of no cloning. That's not just hard, it collides with practical limits so severe that impossible is the only honest casual word. But, and this matters, none of that reduces the wonder of what teleportation actually is: the controlled transfer of quantum information. Here's the rabbit hole people fall into. If a state can move without matter moving,
What is reality made of? Careful. Don't let your brain do a backflip off the balcony. Teleportation doesn't prove we live in a simulation. What it proves is more precise and more unsettling. Information in quantum physics behaves like a physical resource. Entanglement is a resource. Classical bits are a resource, and the state isn't just our ignorance, it's an operational object we can manipulate, transfer, and verify. That's not metaphysics, that's laboratory-grade reality. Quantum teleportation isn't a party trick, it's a foundational operation for distributed quantum computing, secure quantum communications, building quantum networks, and eventually stitching together quantum devices the way routers stitch together the internet. And the arc of progress is visible. Theory in 1993, early demonstrations in the late 1990s, 143-kilometer free space teleportation in 2012, and ground-to-satellite teleportation in 2017. That's a serious technological storyline. It reads like sci-fi because the universe is stranger than our genres. So let's end with the truth, clean and sharp. Quantum teleportation does not teleport humans. It teleports quantum states, the informational blueprint of a particle's behavior, using entanglement plus classical communication. It's not beam me up, it's rebuild the state there and erase it here. And if that feels like magic, good, because what we call magic is often just reality we haven't made peace with yet. Also, if you try this at home, your microwave is not a particle accelerator. It's just a regret machine. If you want the next episode, we can go deeper into entanglement swapping, quantum repeaters, and how teleportation becomes packet routing for a future quantum internet. Like, subscribe, and comment. If you could teleport one thing, but only its quantum state, what would you choose?